right, ladies and gentlemen, we are starting 2.1. We're looking at integers and rationals and all those pretty things. Before we get started of this, I want to explain whole numbers, integers, positive numbers, negative numbers, and rationals. Whole numbers are dealing with 0, 1, 2, 3, and so on. Integers deals with negatives like -3, -2, -1, 0, 1, 2, 3, so on. Positives are greater than 0, negatives are less than 0. A rational number can be made as a fraction. So I'm going to put a little drawing up here, so I strongly recommend you put this on your back of your paper or if you have room somewhere. Okay. We're going to start with this. We've got whole numbers. Whole numbers are 0, 1, 2, so on. Then we've got integers. Integers are like -3, -2, -1, 0, 1, 2. Rationals are your fractions and your decimals that end or repeat. Okay? If I say number 2, 2 is a whole number, an integer, and a rational. Okay? If you're an integer, you are also a rational. But if you're a rational, you're just a rational. Okay? So you go in to out. If you're a whole number, you also have to be an integer and a rational. If you're an integer, you're also irrational. And if you're irrational, you're just irrational. Again, if your back is facing me, you guys feel free to move your desks. You can move your chair so you're switched around. I don't want you to break your neck and keep turning around. All right, I'm going to go back to the first page. All right, we're going to look at a number line. We're going to draw a pretty number line on our paper. We've got 0, -1, -2, -3, -4. We're looking at -3 and -4. Which one's closer to 0? -3 or -4? So which one's bigger? -3. You'd rather only $3 than only 4. Yes? That's Shark Tank. It's also right here on the board. It's the same thing. Okay. All right. Sean, why don't you move up while I'm doing notes? Okay, I'm going to go back to the first page, but again, it's right here. Okay. All right, we're going to look at a list of numbers, and we're going to say if they're rational, whole, or integers. Number 5. The number 5, that is what? If it's whole, it also has to be a what? Integer and a rational. 0.6. 0.6. Whole, integer, rational. Rational. -2. Is it a whole number? Is it an integer? Yes. So it's also rational. 2/3. Rational. And apparently I erased it. -24. Whole number? Integer? And everything that's an integer also has to be rational. Okay? It's like a bullseye. If you hit the middle, you get the points and all the points on the outside. If you hit integers, you also get rational. If you hit rational, you just get rational. Kind of make sense? Okay, let's turn the paper over. You've got a pretty chart on yours. A star's color index is a measure of the temperature of the star. The greater the color index, the cooler the star. So the bigger the number, the colder it is. Order the stars in the table from hottest to coolest. We're going to label it from the smallest number to the biggest. Please raise your hand if you can tell me what the smallest number on that table is. Yes, Anna? come next? Please raise your hand. Jeffrey? Negative 0.03. What would come after that? What would come next? Olivia? 0.09. And so the biggest would be 0.21. All right, example 4 is pretty much done for you. It's just explaining opposites. So if I give you 5, what's the opposite of 5? Negative 5. What's the opposite of negative 2? Okay, that's what I mean when I say opposites. Now let's look at absolute value. If I said, what's the absolute value of negative 2, what would it be? 2. If I said, what is the absolute value of 3, what would you say? Positive 3. Everything you put in the absolute value is positive. Do you guys see the difference between positive and opposite? Yeah. Okay, that's really important. The 2 at the top I just made up. They're not on your paper. Because your paper has examples already on it. So I just gave another example. Sorry to confuse you, Jeff. All right, let's move on to 2.2. Let's turn it over to 2.2. Okay, with 2.2, we're looking at adding real numbers. But we've got some important properties to go with those real numbers. We've got the closure property, which means the sum of any 2 real numbers is unique. Now I've got an example of the commutative property. So you should probably write this down for commutative property. 2 plus 3 is the same as 3 plus 2. So 2 plus 3 gives you 5. 3 plus 2 also gives you 5. Doesn't matter which order you add them in. It can be reversed. Associative property. Here's an example of associative property. 3 plus 4 in parentheses plus 2 is the same as 3 plus 4 plus 2 in parentheses. Doesn't matter where the parentheses goes if it's all addition. Okay. We got the identity property. Anything added to 0 is itself. 0 plus 3 is 3. And then we've got the identity property. Not the identity. The inverse property, excuse me. Negative 2 plus 2 equals 0. Any number plus its opposite gives you 0. 3 plus negative 3 gives you 0. All right, ready to try some of these? Okay, I think of these 2 ways. One we're going to start with, we've got negative 2 plus 5. So I'm at negative 2 on a number line, and I go 1, 2, 3, 4, 5. And I end up at 3. Another way to think of it is you owe me $2. Hopefully, Irene, everyone's writing down everything I'm writing on the board. You owe me $2, you get 5, so you end up with $3. So let's look at number 2. You have $2, but you owe me 6. Do you have money or do you owe me money? No. We owe me money. How much do we owe me? Okay. All right. Now, some people get confused with the addition rules and the multiplication rules. So you got to think of it like money. You owe me $4, you borrow 9 more. Do you owe me money? Yeah. How much do you owe me, Jenna? Good. Don't get messed up with 2 negatives. We're not doing multiplication. Okay, you have $3, but you owe me 9. How much do you owe me? Olivia, who raised her hand? What? Negative 6. Thank you. Okay, let's move on to the last one. We've got one with the associative property. 4 plus the quantity of negative 6 plus 9. So we're going to do inside the parentheses first. You owe me $6, but you have 9. How much? Do you owe me money? Do you have money? How much? 3. And then 4 plus 3 gives us 7. Okay. So if the number line works for you, draw a number line on your paper. If thinking about money works for you sometimes,